Hello students, I am Sailesh Prajapati from Saraswat School. Today I explain Determinant chapter part 6. In this part 6, I explain today properties of determinants. Yes students, properties of determinants, that is already I remaining parts in the 4.2 related exercise running here. Okay, now start. Properties of the determinants, there are the total mainly 6 theorems. It means there are 6 total rules. So one by one I explain in the detail wise all 6 theorems. So first theorem, the value of the determinant remains unchanged if its rows and columns are interchanged. It means students, if you all row converted into all columns, definitely value of determinant does not change. So let's start. Consider del is an assumption for any determinant a1, a2, a3, b1, b2, b3 and c1, c2, c3. And this solution you know that according to definition wise a1 minus a2 and a3. And further calculate up to that you known students. Now I start applying our property number 1, interchange all row elements into column elements. So by interchanging the row and the column, you get the del is a A1, A2, A3. Students just see here, I just highlight this your row A1, A2, A3. Now I converted into columns A1, A2, A3. Same as second row, you write down the second column and same as third row is converted into third columns. So this rule is applied by interchanging row to columns. Clear? Now if I expanded these all values, definitely you gain to same answer to your first del value. It means del is equal to del 1. Exercise example 6. Verify the property number 1. So first of all I explain del by the first row elements and calculate you getting minus 28. Yes students, your answer is minus 28. This answer if you are first determinant del expansion. Now after that property number 1 utilize all row converting into columns. So interchanging row and columns you get that new determinants. Students one more time check. This your first row 2 minus 3 5. Here I mention in the column. Similarly, second row you write down second column. Third row you write down third column. So if property number 2, students one more time I repeat, there are total 6 properties. So all 6 properties first I properly explain detail wise, then after I start our definition related to numerical. So property number 2, if you any two row either columns interchange, the sign of the determinant are changed. This property utilized to both way, row wise also true and column wise also true. So consider del is a a1, a2, a3, b1, b2, b3 and c1, c2, c3 and expand by the first row you getting that values. Now interchanging any two row students, here there are total 6-way explanation any two row, but here I explain you for easily explanation first and third row interchange. One more time repeat students, you apply this also column wise. Any two column interchange same result coming, either any two row interchange first second also true, second third also true and first third also true. I here taking first and third. So expanding by the third row, sure my answer is a according to original del here convert. Verifying property 2. So first of all given del I explain by the example 6. Already it is example 6 repeat here students. That's why here direct answer written. It is minus 26. Already explained in example 6. Now I operating any two row either any two columns. So interchanging R2 tends to R3. I again repeat you students. Any row you interchange, sure your answer is additive inverse. Means minus 28 answer if you original. My new answer is plus 28. Here I operate second row and third row interchanging. So you get it. This your second row and third row interchange. It means students this way your second row 604. But I write down in the third place 604. And third row 1 5 minus 7. This is your return in the second row positions. And now explain by our definition rule. So sure, further calculate, you get out 28 answer. Yes students. Property number 3. So last two properties, one more time I repeat. First property is a any two row, sorry, not any two row, all row interchange into all columns. New determinants are same as to original one. Second one, any two row interchange, either any two column interchange. Your new determinant is the additive inverse of original. Now your third one, any two row, either column are identical. Students, here one word identical. Identical means same. Means any two row same. Either any two column same. Sure, your determinant value is 0. Very easy. Take out simple way to one determinant. We have to interchanging R1 tends to R2 and applying the property number 2. Okay, I just explain here you. One of the determinant I taking 1, 2, 3, and second row is also I taking same as 2, 1, 2, 3, and third row as you wish any number write just like a 4, 5, 6. Look at that. Here two rows are same. Means sure after expanding the first row elements your answer is 0. For example taking I only as students. Now continue. Property number third done. Now fourth property. Any one row, either column, you multiply by constant k. Sure, you get new value is a multiply value of original k. See, I explain by solution wise. Del consider A1, B1, C1, A2, B2, C2, and A3, B3, C3. I just multiply by first row. Students, here total 6-way explanation is done. First row wise, either any two row wise, either any column wise. So 3 row, either 3 columns wise. You calculate, they get the value for this is same. Now I explain by the multiplication k. So multiply by k first row. Now here one of the simple you remarks to write down. First, by this property we can take out any common factor. Any common factor without 0. So k is any common values for row wise either column wise. Second, if corresponding elements of any two row either column of a determinant are proportional. Proportional means it is same value. Then value becomes 0. So look at that in the remarks. Here your two rows are same. First row and third row. If you common taking k, that's why your answer is 0. And R1 and R2 are proportionals. Next, example number 9. Students, example 9 is a board question. Evaluate without expanding, not apply the definition, apply by your theorems. So first of all you check where is the common. Very easy. In the first row something common available there. Students, just check what is the common here. It is common to definitely here 6. So 6. Now property number 5. Students, total 6 properties here. First of all I step by step explaining. After that I go to numericals. Property 5. If sum of all elements, row and columns of determinant are expressed as a sum of the two or more terms, then we can express as sum of the two determinants in individually. So see where it's very easy. Here a1 plus lambda 1, a2 plus lambda 2. You just focus about the first row. Students, this property is also explaining by total 6 ways. Means R1 wise true, R2 wise true, R3 wise true. Otherwise, column 1 wise true, column 2 wise true, and column 3 wise true. It means 6 way it is proved. Here I explain only first row wise. Look at that. Plus given, you write down both are separating. Means A1, lambda 1. Students, one more time I just explaining you. This A1 plus lambda 1 both are separating from the here first case. These are. Similarly, look at that a2 plus lambda 2 separate. Now, example 10. So before starting this example, you just check where is given to additional form. So here given the additional form in the second row. So I easily two determinants are separated by the second row related. Students, this property explaining by row wise also column wise. So a plus 2x. So look at that is a and this 2x. I both of the separated. One of the a here, 2x is here. Same as b and 2i. It is called b plus 2i. And same as here C and 2z is also next. Now last property number 6. This property is a very most IMP. Very most IMP means already asking in your exam. Look at that. First I indicate the red margin. Ri tends to Ri plus RKRJ. Either Ci tends to Ci plus KCJ. These two properties related. These are property theorem 6 I explained. So first I read the heading. If to each element of any row or column of a determinant the equimultiplication of corresponding elements of other two rows are added, then value of determinant remains the same. Don't worry students, I explain detail one by one. I am sure I think you nothing understood here. So I first of all let the day a1 a2 a3 b1 b2 b3 and c1 c2 c3. This property is also explained by total 6 ways, 3 row wise and 3 column wise. So first I going to this are explaining by k multiply for row 3 and adding into first row. Students, these are row 1 I just made by this property Ri. So one more time repeats. First of all, before starting our numericals, one of the remark. Students, you by heart this remark. Any row Ri, k times you write down. Now, example number 11. Prove that a cube is your answer. Before starting this sum, students, it is IMP sum already asking in exam for 4 marks. It is 4 marks question, students, and board questions. Okay. So first of all, check how many determinants are given. So you check here, it is a 2 and here it is a 3 terms and here only 1 term. So finally your determinants is a 2 into 3. It is a 6 determinants given. So if you expand by theorem 5 wise, it is a total 6 theorems. Now I explaining one by one without any expansion. Answer is coming a cube. So first of all, check and how can I prove here internal is 0 coming. So always you operate theorem 6 first, students. Always operating theorem 6 first and think about how can I converting given terms in the 0. So here I look at that first row multiply by numbers from 2 and subtract in the second row, sure it becomes 0. So I just go to this way and same as first row multiply by which number without expanding prove that answer is 0. So first of all look at that between plus, so you create them anyhow in the 0 form. So I just operating first row in the adding second row, this second row add them and you getting x plus y plus z, and after that you common taking this full value is a common x plus y plus z. Definitely students, if you common that taking your values is converting here. Example 13. 1 1 1 A B C B C C A and A B and answer is represent in this form. Students, one more time I repeat, always apply theorem 6 and anytime you just think about how can we create zero value. So students, here I just example you explaining for the zero value. R2 minus R1 is 0 definitely. Either R3 minus R1 is also 0 definitely. Either R2 minus R1 is also 0 definitely coming. Either 3 minus 1 is also 0 definitely coming. Either 2 minus 1 is also 0 definitely coming. As you like, there are many ways. In the many ways, I just operate one. R2 change, R2 minus R1. So, I getting this value. Means first row as it is, second row subtract from first row, and also third row subtract from first row, and you getting 0 0 b minus a, and here a. Example 14. Example 14 is also IMP sum students. So before starting, this sums is in list in the IMP. Okay, so first of all, you think about to zero represent, either try to common taking. So I just apply to first of all common taking. It means R1 change, R1 minus R2 minus R3. It means students, I just operating to this value is subtract from first row. This full value, second row full value subtract from first, and also third row is also subtract from in the first row. Definitely a zero here. Sorry, students, don't worry. I one more time moving this slide by mistake. I calculate. So here are the finally you create 1 plus x plus y plus z. You get that this all are the non-zero. Only 1 plus x y z is a 0. And here our sum is done. So next one. Next one. Example 16. Look at that in example 16. This also IMP for 3 marks. And first of all, look at the question. Your target is achieving here A, B, C outside. So I common taking row wise A. Either column wise is also true as students. Second row common taking B, and third row common taking C. So taking common factors ABC from R1, R2 and R3. So you getting just ABC carry forward outside, and first row converting 1 by A plus 1, 1 by A and 1 by A. Similarly second row and similarly third row. So finally I just added these all numbers. Why students added here? Because you want to this value 1 plus 1 upon A, 1 upon B, 1 upon C. If you adding second row in the first row and third row in the first row, definitely you get at this value 1 plus. Now exercise running 4.2. Very easy exercises students 4.2. From 1 to 7, prove that using properties of determinant without expanding. Yes, students, look at that. Here written without expanding. Means you not operate by the definition first of all. In the ending after 0 represent, you apply by the definition wise. Now, first of all, x plus a, y plus b and z plus c. Look at that. Here you are given one of the plus value. So apply by theorem 5 wise. Either you direct subtract, both value is true. I just operating first and second column added. 4.2 question number second. Here 2 and 2, total 8 determinants are given. So first of all you think about anyhow 0 operating. So I operate here column 1 as it is, but another 2 column adding in the first column. Yes students, second column and third column adding in the first column. Students, it's not necessary every time you adding in first column. You also try to first column and second column in the third column addition. Then you also same getting either row wise is also true. Sure, you get the value is 0 0 0. 3 0 at a time, same in the row obtained, either column obtained. So definitely you can say all entries of one. 4.2 continue. Question number 3. 65, 75, 86. Yes, students, this sum is also IMP question for 2 marks. Already asking in exam. This IMP. Without expanding, I prove anyhow this answer is 0. It's very easy. Look at that. Highest number 65, 75, 86. You just think about the highest number first. So second column subtract by the first column. You getting 65 minus 2, 72 minus 3 and 80. It is theorem 3. Now 4.2 continue. Question number 4. Very easy. Multiply by first of all A inside ABAC, BC, BA and CA, CB. Now second column, if you adding in the third column, definitely you getting the same column and same element. That's why my answer is 0 coming. So I just adding C3 and C2. You get it that values for AB. Next 4.2. This numerical are big numerical and IMP for exam. It is 3 marks questions. So students, this sum also I highlight in IMP list for 4 marks. Look at that. Here you operate row wise, not operate by column wise. This row and this row, if you adding, then you get the some like terms. So I start the row wise. First of all, LHS. And LHS wise, just adding you to 0 either in list term. So R1 minus R3, very easy. And R3 minus R1 is also same. So finally you getting BQR and last getting APX. Now students, anyhow you think this row subtract from this row, then definitely A gone, here P gone and here easily X gone. Only Z is remaining. So my answer is done here. Only and only R2 minus R3. So it is represent BQY and CRZ and APX. Now look at that students. Your numerical is not done. So you interchange any two row either column, then you create the answer is your RHS. So interchanging R2 and R3. Students, these R2 and R3 are interchange. Means these are second row. Now continue 4.2. Question number 6. Without expanding, prove that answer is 0. Look at it students, here only already 3 zeros is given. Whenever you 3 zeros already given, you operate here two things. One of the row to column interchange and minus common taking row wise either column wise. Then you can prove answer is 0. One more time repeat. Whenever you diagonals wise 0 given and you proving the answer 0, then you operate minus common row wise either column wise and Ri tends to Ci. It means row wise to column entry interchange. So I start our LHS and taking minus 1 common to each row. I telling each row, it means there are 3 row 1, row 2 and row 3. So there are 3 minus value common taking and applying Ri tends to Ci means interchanging row and columns, the value of determinant R does not change. It is your theorem 1. So they getting minus 1 cube is minus 1 and other are row 1. I written here column 1. Students, these are interchanging. Row 1, 0, minus 4.2 continue. Question number 7. Very easy. Look at that common taking row wise either column wise. So here you common take to first row A common. Similarly B also common to second row and third C column also C and column wise is also common here. See, in column 1 A, column 2 B and column 3 C. So I just operating the common taking first. In the LHS, common take A, B, C to respectively R1, R2, R3. You remaining at that and again common take to column wise ABC. So you also then apply either operate R1 plus R2, you getting directly 0 answer. Two zeros and here twice C and get to apply simple by solution of our definition wise. Students, when you apply the definition rule, question number 8 to 14 by using again properties rule. So eighth one, 1 1 1 a b c a square b square c square. Students, anyhow you think about 0 represent. So before starting I just operating 0. How can a 0 represent? So I just give you some examples for converting your zeros. See here, a minus a is 0. Either this minus is also 0. Either second row subtract in first row, either third row subtract in first row. So anyone you operate as you like, students. It's very simple. Now operating R2, R2 minus R1. So what is R2 minus R1? It's the 0, and R3 minus R1, this is also 0. So my answer is a 2. 8 the second one. Same as 8 the second one. Think about how can here is also 0 coming. Students, 0 is a very simple. Look at that. I just give you some examples. This one column, subtract here. These are 0. Either first column, subtract in third. These are 0. Either as you like. Other two columns, subtract in the next two ones. So, C2 columns, C2 minus C1. I mean C2 change. And C3 change, C3 minus C1, you getting that 1 0 0, B minus A, C minus A, B cube minus A cube, and C cube minus A cube. Now formula wise you just expanded by the column. So further calculate simple principal diagonals minus secondary diagonals, and I create the square value is a combined return. Means C square minus B square. These are the cancel, huh? A square and A square here gone, and C square and B square I written here, and other are same as, and here common taking, and you moving the in the two factors values, C minus B, C plus B for two factor is this. Question number 9. This is also same sum, and think about 2. How can 0 coming? Either common coming. So very easy. Here power it is not same. So I just multiply R1, R2, R3 by X, Y, Z respectively. It means first row multiply by X, second row multiply by Y, and third row multiply by Z. Students, whenever you power it is not same given, then you apply this property row wise multiply. So whenever you multiply, you write down here 1 upon dividing also X, Y, Z. By mistake I not written here, don't worry. And property same written. Formula, right? Y square minus x square is a y minus x, y plus x. Same as z square minus x square is a z minus x and z plus x. And this side, right side, cube formula, right? And common taking, and further expanded by principal diagonals minus secondary diagonal, and fully multiply. Definitely you getting some cutting values. Students, here many values. Yes. And now common taking and arranging by the two property z minus y and z plus y. Here two properties, right? And these are the common taking here. And in this part is also common taking. And finally you common taking z minus y outside carry. So you get that value and further expansion and re question number 10 first. X plus 4, 2x and 2x, and you proving 5x plus 4, 4 minus x square. So very easy. Your LHS first, think about 2. Only for common wise, either preparing 0 wise. Students, both ways true. Here common taking wise. So row 1 are adding to row 2 and row 3. It means second row and third row. Both of you adding in the first row. Definitely if you added, students, it is not necessary row wising operating is fixed. You also operating column wise, same answer coming, huh students? Yes, same answer coming. So if you adding, then you getting the 5x plus 4, 5x plus 4 and 5x plus 4 common taking to first row wise. Now look at that. Here you create two zeros is easily. 1 minus 1 here 0 coming. Either 1 minus 1 here 0 coming. Definitely you move ahead in the 2 0 wise form. And column 2 minus. Now 10th second. Same representing LHS. This numeric is also students as you wish. You calculate row wise either column wise. So I operating only column wise now. So column 1, column 2, column 3 adding in the first column as you like, adding in second column is also true. So first column, in the first column I adding second column and also third column adding. So what you get? 3yk, 3y plus k, 3y plus k common taking. So you get this outside common 3y plus k. Other are 1 1 1 converting into forms of 0. After that, if you common take already done, then you represent zeros wise. So C2 common, C2 minus C1 and C3 change, C3 minus C1, and after that expansion, you get the little value k square outside and 3y plus k. It's a very easy. Now question number 11. 11th first. Very easy. A minus B minus C, 2B and twice C. Same as this. Here also you done by adding R1 plus R2 plus R3. It means first row, second row and third row. Both are adding in the first row. So this both row I adding here. Then you getting here A plus B, B plus C and B plus B plus C. And this after that in the next steps I just common taking. Common take outside. Now think about 0. It's very easy. 0 is also represent. Look at that. This 1 minus 1. This 11 done here. 11 second is a big sum because here 3, here 3 and here 3. Total 27 determinants are given. Here 3 property, here also 3 and here also 3. So don't worry. Here also you operate row wise, either column wise. It's very easy, some students. I just operate simple. First of all LHS definitions wise. So these are the previous steps. Don't worry, students. These are the previous steps. And now expand by definition ways. Definition you know. Whenever you more than 2 0, either 2 0 coming in the solution, you going to definition wise and definition wise. Now I move ahead. Question number 12. 12 also very easy sum. LHS 1x x square, x square 1x and 1 x square x. Students check here. Your power it is not same. Whenever you power it is not same, then you just multiply either added. See here I adding the 1 plus x square and x cube, r1 r2 r3. Common take outside. It means here common students. These are the common. Take outside. It means that are the outside taking. Now previous step again I return here students. Don't worry. And 1 minus x square I show 1 minus x and 1 plus x. Common taking and further expansion you get that remaining values. So 1 plus x square the whole square and 1 minus x the whole square. That's my finally answer to whole square, and that value is a formula for a cube minus b cube. I mean 1 minus x cube the whole square. So that's my little answer. Question number 13. 13 is also 3, 3 and 3, total 27 determinants are available according to your theorem number 5. Students, if you are asking how many determinants here, so 3 into 3 into 3. Why I write down 3? Because look at that, in the first column there are total maximum 3 additions given. Here is also 3 additions given and here is also 3 additions given. So theorem number 5 wise, it is a total 27 determinants are distinct given. Now I start for solution wise theorems. So given terms is as it is. Here I am going to by definition wise. This is the previous steps and definition wise calculate and going to answers further expansion principal diagonals minus secondary diagonal, you getting RHS. What is your RHS? 1 plus a square plus b square. Actually these two are the like terms students. property same continue 8 to 14 numericals. Here 14 are also IMP sums, and it is IMP for bold level. It is a 2 marks question, but many time asking in exam, students, because here poverty look not same. Whenever you poverty not same, then you operate row wise multiply and column wise common. So students, here I row wise multiply. First row multiply by A, second row multiply by B, and third row multiply by C. And after that common taking column wise. Either you column wise multiply and row wise common taking, then definitely your poverty is same. Students, this process only and only for making poverty same. Look at that. Is all poverty is same. Absence of constant. Now, easily you adding, you getting the 1 plus a square plus b square plus c square. You just add them, column, common taking I. These are previous steps, ABC common and cutting. Now, 1 plus a square plus b square plus c square. These two values are common outside. Yes, students, these are the common outside. 1 plus a square plus b square plus c square. These are the common. So remaining I have to 1, 1, 1, and after that easily I create zeros value, because second row change with the first row and third row change. It means question number 15. 15 is a simple sum. The MCQ Ka is equal to dash. So let them. A is an assumption. A11, A12, A13, A21, A22, A23, and A31, A32, A33 in the square matrix 3 cross 3. Now I multiply by K to each determinants. Surely you getting Ka11, Ka2, Ka3 now applying in the matrix form for the determinants form. So you common take. So students, here common is available to row wise K1 available. Second row wise is again K available, and third row wise is again K available. Either you operate column wise is also true. So there are 3 K available. 16. 16 is also very easy. Which of the following is correct? Options are there. Determinant is a square matrix. Determinant is a number associated to a matrix. Determinant is a number associated to a square matrix, and none of this. So definitely your answer is known that determinant is a number associated to a square matrix. So my correct option is C. Yes, it is a simple definition wise. I just explaining you here, students. Yes, here students, we happily and successfully our period 4 and 6 part ended here, and here I homework as well as little thoughts for you. Fear has two meanings: forget everything and run, otherwise face everything and rise. The choice is yours. One more time. Fear has two meanings: forget everything and run, otherwise face everything and rise. The choice is yours. So as you wish, anyone you choose, definitely you going to your success path. Thank you very much. And students, here our 6th part is over here, and further study I explain you in the 7th part. That is the last part of our this chapter. So thank you very much, and thank you for seeing and properly understanding this video. And students, if you any doubts, I explain you in the school class period. Okay, don't worry. Thank you. Bye bye.